Good day, everyone. I welcome you back to Global Education Zone, the home of impactful learning. It's nice over here for you and I because learning never ends and education is the key to an impactful life. Hey everyone, I welcome you back to Global Education Zone. My name is Anthony Nathaniel. Now, in this particular episode of our Crash Mathematics for Senior Secondary School 3 or SS3, we'll be dealing with latitude and longitude. Now, latitude and longitude is a very important subject in mathematics because a particular section is devoted to it in your WAEC examination. It often occurs in your WAEC examinations and either it comes out or is replaced by bearing and distance. So that is a knowledge for those of you who have been studying the trend of the questions in WAEC. So, but today we are not after WAEC questions. All we are after is, as always, we are dealing with the background, the rudiment. I'm talking about the basics. And for those of you who are having issues with the concepts, this video is for you. So you need to sit down and listen carefully. Now, today I'm talking about latitude and longitude. And latitude and longitude is that topic that simply talks about those lines on the Earth's surface. Now, when we talk about the lines on the Earth's surface, there can be different nature of the lines. The lines could run from up to down, or they could run from side to side. Now, based on the direction in which they run, they have different names. For example, the ones that run from up to down or from north to south, they are called the lines of longitude or the meridians of longitude. Then the ones that run from side to side or from left to right, or you can also say from west to east, they are called the parallels of latitude. Now, today, aside dealing with the rudiments, I will be also solving some questions in latitude and longitude. So you need to keep your bag strapped and keep your pens and your paper and whatever you have. So sit tight and learn. Now, basically, if we look at the Earth, how it looks like, the Earth is basically a sphere. Now, you can see that the Earth looks like a sphere because it is just like the 3D projection of a circle. Now, a sphere is like the solid projection of a circle. So any direction you look at a sphere, it will appear as a circle. If you look at a sphere on a plane surface, it will be as a circle. Now, if you cut through any section of that sphere, you will get a circle. As you can see, if you cut through any section, both up and down, when you cut through any section that is perfectly horizontally or perfectly vertical, or even if it's inclined, no matter how you cut, whether you cut vertical or horizontal, or you cut inclined, you will still get a circle as the true shape of the cut surface. So if you are apt in geometry, you will understand what I'm saying. But if you don't understand, and even if you are not apt, you don't need to understand completely. So what we're interested here is in the concept. Now, as I said earlier, when you cut those when you make a vertical cut, you would see that outline of that cut is just like what we call a meridian of longitude. And that vertical cut, they are like the lines, those lines that run from north to south, they are called the meridians of longitude. And those lines that run from side to side or from west to east, they are parallels of latitude. Now, the meridians of longitude, they run from, you have the reference point, which is the Greenwich meridian, which passes through London and Accra in Ghana. Now, those two locations, they are used as the standard because the Greenwich meridian line of longitude passes through those locations. So, and then when we measure any location to the east of those locations, those are called eastern direction. So when we measure any location to the east, they have an eastern longitude. When we measure any location to the west of that and Greenwich meridian, they are called the western longitudes. So, and then there's one quick tip for you. Anytime you move to the east, you always gain time, and anytime you move to the west, you always lose time. The reason is that it all lies in geography. Now, the thing is, our Earth naturally it rotates from west to east. Now, so the sun rises in the east and sets in the west. Now, in this case, when you go to the east, you are moving into the direction that the sun is going. So as a result of that, you are moving in the direction of the sun, and then the sun is will be shining over that place. So but when you are moving to the west, you are moving opposite to the direction of the sun, because the sun is moving from west to east. But when you are moving from east to west, you are moving opposite the direction of the sun, or rather in scientific and technical terms, you are moving opposite the direction of rotation of the earth. Now, so that I will not delve into geography too much, because I'm also a geography student, so it's easy for me to assume that you all understand what I'm saying. But the fact is, I might be wrong. So let me stick to mathematics. Now, in mathematics, we'll just call these the lines of latitude, and these lines of latitude, they are called the parallels, because they are parallel to one another. As you can see, they are always parallel to one another. So you can see the pictures. The lines of latitude, they always run from side to side, and they are parallel to one another. Now, the lines of latitude, they have a reference line which is called the 0-degree equator. Now, these lines of latitude, they are like the lines that mark the rotations. Now, on a particular line of latitude, for example, on 0-degree of latitude, which is also known as the equator, on that 0-degree, the angle of rotation from the center of the earth is 0. So basically, you can simply understand this as lines of latitude are simply the angle of rotation between the horizontal plane through the earth. When you cut a horizontal plane through the center of the earth, so the angle between that horizontal plane and a particular plane and a particular line, so or rather on a particular point. So if you group all those points together and connect them, they form the latitude. And that latitude, it has a particular degree, and that degree of latitude is like the angular displacement from the horizontal plane. So it is basically angular displacement of a particular place from the center of the earth. Now the same goes for the same goes for longitude, but this time around longitude is like the angular displacement from a vertical plane. So when you have a vertical plane from up to down, so when you displace from that vertical plane, that angular displacement is the longitude of that place. So that is, and this latitude and longitude, they are used for locating of places on the earth. So you use them to locate the place on the earth. And then let's talk about a little bit of constants. Now, the earth, for your examinations, you'll be given that the earth, often in WAEC, they always give that the earth has a radius of 6,400 kilometers. Now, no matter where you are, even if you are not sitting for WAEC, even if you are just watching this video just to learn, but just know generally that the approximate value of the radius of the earth is 6,400 kilometers, and then the approximate value of the circumference of the earth is 40,000 kilometers. Now, the radius of the earth is the distance from any point of the surface of the earth to the center of the earth. So when you, like, I'm standing on the earth surface now, so the distance between the center of my mass, and the center of the earth is 6,400 kilometers approximately. So that is accounted when you just approximate all the mountains and all the valleys and all the displacement. So you have the approximate value 6,400, and then when you measure, just like when you calculate the circumference of a circle, you can also calculate the circumference of the earth. Now the circumference of the earth is basically the distance around the outline of the earth when you look at it as a hemisphere. If you cut the earth into two and you trace the path around that around the edges of that cut, so that's kind of like a circumference. So now, moving on, that's another concept. Now let's talk about the concept of different types of circles. Now you can see earlier that in the picture I displayed earlier, I talked about the circle. When you cut through different planes, different positions, you have different circles. Now basically, when you cut through the center of the earth, you have a great circle. So a great circle is any planar section of a sphere that passes through the center of the earth. So, or rather of the sphere. So because the earth is a sphere, the great circle is basically any planar section that passes through the center of the earth. So, and then the small circle is any planar section that does not pass through the center of the earth. So that's the difference between great circle and small circles. Now, as I mentioned earlier, we have the lines of latitude and lines of longitude, right? Now those lines of latitude, they run from left to right, right? Now, out of the lines of latitude, the only great circle is the equator. But when we talk about the lines of longitude, every line of longitude is a great circle, because every line of longitude always passes through, is always drawn from the center of the earth. But the only line of latitude that is drawn from the center of the earth is the equator. Now you will have heard of that in your geography classes, so I don't need to elaborate more on that. let's move on to the next concept. Let's talk about the let's talk about the calculations now. Now in this concept, what we'll be dealing with is the calculations, and there are some strategies involved. For example, we have what is known as the hemispheres. Now, just in case you are rusty in geography, let me just touch up on some fundamentals. Now, in geography, we know that the Earth has the northern hemisphere and the southern hemisphere, right? Now, there's just one simple logic that makes latitude and longitude special. So this logic is that anytime you have points on the Earth's surface that are in the same hemisphere, you subtract their latitude. So the latitude, every point has its own specific latitude and longitude. So you subtract their latitude when they are in the same hemispheres of the Earth, and then you add up their latitude when they are in the same in different hemispheres of the Earth. So what that means is that latitude, the latitude or the angular displacement of those points is basically equal to the addition of their latitude, of their respective latitude when they are in different hemispheres, and also it is equal to the subtraction of the smaller from the bigger latitude when they are in the same hemispheres. Now, just in case you don't understand all these points, let's delve into a calculation that will demonstrate all that. So this calculation will be like an embodiment of what I've been saying so far, and pay attention closely. Now, this question will say there's a location in X in, okay, let me read the question out. Sidi Barani. So I don't know how to pronounce all these foreign names of cities, but there's a city in Egypt called Sidi Barani. Egypt and Gabon in Botswana both lie on longitude 25.9 degree east. Their latitudes are 31.6 degree north and 24.8 degrees south, respectively. Calculate the shortest distance between the towns. Now, in this kind of questions, these are the steps I would take to solve, and these are the steps I assume you should take to solve to be on the safest side. Now, in these questions here, the first thing you are going to do is you are going to sketch a circle. You don't need to be perfect to see, just sketch any circle, a rough sketch of a circle. Mine is relatively big. On the paper, you can just sketch a circle if you are walking along with me. Now, then you begin to locate the points. Now, let's read the question all over again. Now, these points, the Sidi Barani in Egypt and Gabon in Botswana, they are two different locations, but now they said they both lie on the same longitude, 25.9 degree east. Now, first of all, the longitudes, they always run from north to south, as I told you earlier. So there's the North Pole and this is the South Pole. That's touching up from some concepts in geography. Now, this North Pole to South Pole, we have what is known as the Greenwich Meridian, which is this kind of like the reference point of all lines of all meridians of longitude. Then now, when we take this one as a reference, they said they both lie on longitude 25.9 degree east. So that means instead of going west, we are going east. So we are the displacement or the latitude where these points lie, these cities lie, this longitude, the latitude where these cities, the longitude where these cities lie, they are located on the eastern side of the Greenwich Meridian. So this line, this dotted line I drew is the Greenwich Meridian. It's representing it now, because all these lines, so let me add that they are actually imaginary. They don't exist, but they are actually the kind of like they are used to benchmark and to help us provide a reference for which to know the positions and distance between points on the Earth's surface. That's just in case you are wondering where they came from. Now, so let's just create an imaginary line. This will be the latitude, the new latitude, and this is 25.9 degrees east. So that means from here to here, this angle here is 25.9 degrees east. So from this latitude and this one, let's call it 25.9 degree east. Now, these points, they are located on this latitude, but we don't know exactly where they are located on this latitude. Now, this latitude is like a circle. What we are seeing here, we are seeing only a half of that circle. On the other side, yes, it also has the other half of the circle, but this circle will represent the longitude of 25.9 degrees east. So it's eastern of the Greenwich. Now, what will help us to locate where specifically where they are on this line, what will help us is the latitude. So this is the longitude, know their longitude, but now what's their latitude? Their latitude is at 31.6 degree north and 24.8 degrees south, respectively. So now here we'll now draw another reference. This will be our equator. So assuming this is the equator, 0 degree. Equator is naturally 0 degrees, so you need to remember that. Don't forget that. Now in this 0 degree, you have 31.6 degree north. That means the first location, which is Sidi Barani in Egypt, is 31.6 degrees. So you know the north is when you are want to locate a place in the north, so it's going to be in the northern hemisphere. So just assume this is it. This is it here. So this is 31.6 degree north. And then the intersection of this longitude and this latitude will give the position of Sidi Barani in Egypt. Now next, let's go to the second location, which has 24.8 degrees south. Now because it's south, we are going to locate it in the southern hemisphere. So we just draw an arbitrary line of latitude in the south, and then where it intersects with the original line of longitude will be our position. So you can see that the lines of latitude and longitude, when they are combined together, they intersect at a position, and that position is the place that you are given. Now this is, let's call this 24.8 degree south. Now the question now proceeds to ask us to calculate the shortest distance between the towns. Now I have the towns here as these nodes, this first node and this second node. What we're looking for now is the distance. Now what you need to do is you just need to be imaginative. Now imagine, as I said earlier, this is a circle, right? Now when we draw this circle represents the line of longitude. Now this circle here, if you are looking, if you want to imagine, be imaginative. Turn your imagination to become a three-dimensional and imagine a sphere, a ball. Let's just imagine that this is a ball. Now in this ball, this is a football. Assuming it's a football, the earth is a sphere. A sphere is basically like a football or anything like that. Now in this sphere, just imagine that this is a circle. Now can we draw that circle? Let's draw a circle. Now if you draw a circle, this circle will represent the meridian of latitude of longitude. This meridian of longitude, it has 2 points. The first point here is Sidi Barani, and the second point is you can see that these points are actually lie on this line of longitude, because we are told in the question that they both lie on longitude 25.9 degrees. So now this is 25.9 degrees, this is the longitude. Now this longitude, they are all great circles, and as such, as I explained earlier, they all pass through the center. The center of these circles, they all lie on the center of the earth. Let's look at this. Now if you can see, we are getting into a very interesting case, because this question is similar to the one you encounter when you are looking for the area of the circle. So what you need to do is you connect the center with the first point and the center with the second point. Now all we need to know now is the angular displacement. Now you can imagine that this is the equator. Now let's draw this line, equator. Now the latitude of this point, it is this angle will be equal to the latitude of the first point, which is 31.6. Just this angle will be 31.6 degree, and then this angle here, the angle below, will be equal to the latitude of the second point, which is 24.8. So if you are following closely, you'll be able to understand what I'm saying. Now you can see that if we want to measure the angular displacement, now in this question we are looking for the shortest distance, right? The shortest distance will be from here to here, because the shortest distance between any 2 points always lies on a great circle. So go and note that down. That is a fact. It can't be changed, and it is even applied in real life, because anytime you have in aeronautics and aerospace, anytime you have a plane moving from one place to another, it always goes along a great circle, because that is the shortest distance to conserve fuel and to save time. Now that's just the tip, and that's by the way. Now back to our mathematical question. You can see that in this question, if we are looking for the shortest distance, it lies on this arc. So let's call these points A and point B. So the length of this arc will be equal to, going back to your geometry classes, you can remember that the length of an arc is equal to the angular displacement divided by 360, then times the circumference of the circle, and the circumference of the circle is given by 2 pi r. Now this is all we need. This is all the toolkit we need to know the distance between Sidi Barani in Egypt and Gabon in Botswana. Now all you need to do is you need to add these angles together. Now if you don't want to go through this elaborate process of drawing these circles and all the rest, all you need to know is anytime they are in different hemispheres, you add their angular displacement. Anytime they are in different in the same hemispheres, you subtract. So now because one is in north and one is in south hemisphere, so we have to add these angles. So when we add the angles together, we'll get a total of 56.4 degree, because 31.6 degree plus 24.8 is 56.4. Then divide by 360 times 2 pi. Pi is given as 20/7 then times the radius of the earth. Now just plug in the radius of the earth to be 6,400 kilometers. So if you plug that into your data, you get your answer. When you work the math, when you calculate everything, you get 6,270 kilometers. So that will be the distance between the two. So you can also try it out where you are. You can see what is theta. When theta is 56.4 degrees, so look for evaluate theta over 360 times 2 pi r, where pi is 20/7, and in addition r is the radius of the earth, which is known as approximately 6,400 kilometers. So when you work the math, you get your answer as 6,270 kilometers, and that will be distance. That will be the shortest distance between the 2 points. Now, I assume you understand that question well enough, because if you don't understand, you can also replay this section of the video. So let me move on to the next concept of this video. Now let's go on to some advanced parts of this video. Let's talk about how to calculate. Now in this particular question, we've calculated based on the latitude difference. So what about if we are talking about the longitude difference? Now this next question, let's talk about this. Now this question reads as: the position of Libreville in Gabon and Kampala in Uganda to the nearest degree are 0 degree north, 9 degree east, and 0 degree north, 32 degree east, respectively. So these are the position of these 2 points. So this position. A position of a point is ensconced in the latitude and the longitude. So when you combine them together, you get the position of the point. So you can see that this is latitude, longitude of each of these points. Now we are asked to calculate their distance apart along the equator. Now in this particular question, what we are dealing with longitude difference. And anytime you are dealing with longitude difference, you always calculate your distance along a latitude, a line of latitude. Anytime you are dealing with latitude difference, you calculate your distance along a longitude, and vice versa. So if your angular difference is on the latitude, then your calculation will be based on a longitude. If your angular difference is on a longitude, your calculation will be based on a latitude. So I'm using my hand to signify the directions: horizontal, latitude; vertical, longitude. Now in this question, in this diagram, you can see that in this question we have the diagram here as this. Hopefully this, you can see that the circle in 3D space, not just as my drawing, but now it's live, just like a circle. Now in the calculations, we have what you need to know is you just need to calculate the angular displacement. So in this case, in this question, they are both in the same hemisphere. So all you need to do is you subtract. So that will be the difference in longitude is 32 minus 9 degree. That's 23 degree. You can see that's angle LOK is the longitudinal difference, and that's 23 degree rather. Now this 23 degree, now you are going to use it to calculate the distance, the position between these 2 points along the equator. So, and because the equator is a great circle, that means the center lies on the center of the earth, and as such you are going to take the radius as the radius of the earth. So that's why in this question you can see the distance between these 2 points on the equator, which is a great circle, the distance is equals to the length of the arc LR, as you can see in this diagram. And then when we calculate everything, that will be 23 degree divided by 360 times 2 pi r, and then our pi is 20/7, and r is the radius of the earth, which is given as 6,400 kilometers. Now at the end of the day, we have our answer as approximately 2,600 kilometers. So two significant figure. Now this particular question is it properly takes in the concept into consideration. Now before we move on to the next concept in this video, let's talk about one part which I would like you to understand. Now in this part, anytime you are given a line of latitude, anytime you are calculating your distance along a small circle, and as such you will be calculating your distance along a line of latitude, because lines of latitude, they are small circles except the equator, which is the only line of latitude that is not a small circle. So anytime you are calculating your distance along a line of latitude, which is often a small circle, you make use of the radius. The radius you'll be using will not be the radius of the earth. So you're making use of a new radius, which is equals to r cos theta, r cos alpha rather, and that alpha will be the latitude of that point. So now that alpha will be the latitude of that point, and that on that point could be 1 or 2 points. So those 2 points, if you are looking for a distance between 2 points, the radius you use is r cos alpha, which alpha is the latitude on which those points lie. So and then that r is, as usual, r is the radius of the earth. So now let me solve an equation that will show you what that is all about. Now in this particular question, this example 5, let's talk about this question. We have that find a distance measured along the parallel of latitude between 2 points whose latitude are both 56 degree north, and whose longitudes are respectively 23 degree east and 17 degree west. So as you can see in this question, we have the distance is measured along a parallel of latitude. So as I said earlier, when you have a parallel of latitude distance, it is often going to be involving a small circle, and as such, you cannot use the radius of the earth. You have to make use of a new radius, which is equal to r cos alpha, and alpha is equal to the latitude of those 2 points. Now you can see, as you can see here, we have the earth and we have the 2 points. So they are on the latitude. This circle that is drawn beside it, it is the circle, and this circle represents the parallel of latitude, and this latitude is 56 degree north. Now this our 56 degree north, which is the latitude, will be representing our alpha. So that's what we're using to calculate the new radius. So as you can see, we have in the triangle ACO, which is in that in that diagram, triangle ACO, yeah, and this triangle ACO, it represents the angular displacement. So it's the angular displacement of the latitude from the center of the earth. So this the new radius of the circle will be equals to 56, equals to r plus 56, and r is the radius of the earth, which is 6,400 kilometers. So when you plug in your values, and then when you calculate your latitude difference, because now you can see that their latitude, their longitudes are 23 degree east and 17 degree west. So that means since they are in different hemispheres, you are going to add. So when you add everything, you get 46 degree, and then you look for the length of arc AB, which is equal to latitude difference rather longitude difference, which is 40 degree. 40 over 360 times 2 pi r. When you calculate everything, you are going to get an answer of 2,490 kilometers, and that is the distance between those 2 points. Now I need to point out that this distance is not necessarily the shortest distance here, because this distance does not lie along a great circle, it lies along the small circle. So if you are looking for a shortest distance, you often make use of the great circle. Now this is as far as we'll go in this video. Now in summary, we've talked about latitude and longitude. We've talked about various concepts. We've talked about, so let me talk about the summary of what we've talked about. We'll talk about any planar cross-section of a sphere is a circle. We'll talk about the fact that latitude and longitude, they are those imaginary lines that represent the position of a point on the Earth's surface, and they also help us to calculate the distance between those points. And then we'll also talk about the great circles, whose center lies on the center of the Earth, and we'll talk about the small circle whose center is not the center of the Earth, but lies on a plane, but lies on the same plane with the center. Now that plane could be a horizontal or vertical or inclined plane. So and then basically on the screen now I will show the summary. You can just go through that if you are still having some issues with the concept, but I hope with this video you've been able to understand fully what latitude and longitude means, and hopefully I will see you in the next episode.